Hi dear students, welcome to my channel. Today what we discuss, conservation of total angular momentum of a system and equilibrium of a system. There are three equilibriums. One is stable equilibrium, second one is unstable equilibrium, third one is neutral equilibrium. Okay, first we discuss what is conservation of total angular momentum of system. Okay, here total angular momentum of a system, L is a vector, is equal to I into omega. Omega is a vector, I is moment of inertia. I is moment of inertia. Moment of inertia formula already I explained in the previous videos. I is equal to mk square. Okay, omega is angular velocity. Angular velocity. Okay, I am taking magnitude only. L is equal to I into omega. This conservation of total angular momentum happens only when net torque on the system is 0. If net torque on the system is 0, total angular momentum of the system conserves. Conserves means what? It is very simple. It is a constant. It will not change with time. It is constant. Okay. So here, if you take some examples, this I is moment of inertia. If it changes, what happens to angular speed? L is angular momentum. It is constant for net torque on the system is 0. In that case, if there is change in moment of inertia, there will be change in angular speed happens. Suppose I increases. Suppose I increases, then omega decreases, such that I into omega constant. Or if I decreases, then omega increases, such that I into omega constant. Constant. Okay, what is I? You know already. Moment of inertia of any object. Suppose I am an object. What is the moment of inertia of my body with respect to one axis passing through exactly middle of my body? So this is one axis. About this axis, you calculate what is the moment of inertia of my body. This is I1. Suppose I am rotating like this with some angular speed. That time I1 omega 1. Now what I do? I stretch my hands like this. This time what happens? My moment of inertia changed. Definitely it will increase because my hands stretched, no? So moment of inertia increased. In this case, angular speed decreases. You can see some examples also. Okay, this is called total angular momentum of a system is constant, or the total angular momentum of a system is conserved. Okay, based on this formula and some kind of experiment also you can see, you can solve a problem. Simple formula is I1 omega 1 is equal to I2 omega 2. This is conservation of total angular momentum of the system. You got it, no? Okay. Now we discuss equilibrium of a system. Equilibrium. Of a system. Here, this is the topic. One object is there. It is lying on the ground, mass m. The object mass is m. Okay. Equilibrium of a system means one system is in equilibrium, means net force on the system is 0 and net torque on the system is 0. Then I call that system is in equilibrium. Here you see this object mass m. What are the forces acting on it? Downward force, that is due to gravity mg, but it is not going in. There is one force that prevent it, that is upward direction, that is a normal reaction force due to this ground. Just like I am standing like this, net force on me 0 because downward gravity is equal to upward normal reaction force. So net force is 0. I can say this object m in equilibrium. Okay. The next question, is there any torque? Net torque also 0 because it is not rotating. The center of mass, okay, here I will draw same figure, but I am drawing again. This is same object, this is the center of mass. At the center of mass only downward force is mg, upward force is normal reaction, and both are equal. Because net torque के लिए, what is the torque formula? Torque is equal to R into F. Here R is 0. Here R is 0. Net force also 0. In fact, net force also 0. R is 0. So net torque on the object is 0. Net force on the object is 0. So we can say this object is in equilibrium. Now next point will go. What is stable equilibrium? What is unstable equilibrium and neutral equilibrium? Stable equilibrium. Stable equilibrium. Here you see one pendulum. This pendulum is in equilibrium. It is not moving, it is not rotating, it is not going anywhere. Okay? This is equilibrium. I want to tell what kind of equilibrium it is. Is it stable? Is it unstable or neutral equilibrium? Then how can we differentiate it? Now take this pendulum to side like this. I am taking here and leave it. What happened? You know, it will oscillate like this and it will go like this and come like this. Finally what happens? If there is a friction force, this oscillations, the displacement decreases. Finally it will come back to original position. If you make some small disturbance for it, after oscillating, it will come back to original position. This is called stable equilibrium. Okay. So what else we should know stable equilibrium के लिए? If object is going from here to here, from here to here, suppose this is C, this is A and this is B. From C to B it is going, its potential energy is increasing. From C to A it is going, its potential energy is increasing. If the object is at lower potential energy, that object is in stable equilibrium. You got it? Okay. Now we discuss unstable equilibrium. Just I will put here unstable equilibrium. Unstable equilibrium means one mountain is there. This is mountain. ऐसा एक mountain है. Okay. इसका top में one object है. One ball is there. One ball is there. Now it is in equilibrium. The ball is not moving anywhere. But we should know what kind of equilibrium it is. Then what to do? Just do this experiment. Just disturb it. इसको थोड़ा ऐसा करो. Then what will happen? It will come here. It will never go back. Agree or not? This is called unstable equilibrium. If you just disturb it, it will move in such a way it will never come back to its original position. This is called unstable equilibrium. What is the physics behind it? You know, potential energy. This object is at highest potential energy position. If you just disturb it, its potential energy is decreased. It will not regain it back without any external agency. If object is at highest potential energy, if you disturb it, it will never come back to original position. It means if object is at highest potential energy, surrounding the potential energy is decreasing, or potential is decreasing, this kind of equilibrium is called unstable equilibrium. You got it, no? Good. Now, one more. Neutral equilibrium. Neutral equilibrium. Neutral. Neutral equilibrium means very well you can take simple an example one object on, you take ball also, कुछ problem नहीं है. Object on a flat surface. This object is in equilibrium. But what kind of equilibrium it is? It is a neutral equilibrium because surrounding the ball, here you take, this is A, this point is C, this point is B. So at A, at C, at B, potential I am calling VA is equal to VC is equal to VB. Means surrounding points A and B also at same potential level. If you just keep this object here, it remain there. If you keep this object here, it's remain there. If you disturb like this, it may go somewhere and it will stay there only. It will not come back. This is called neutral equilibrium. I hope you understood. Okay. So conservation of total angular momentum, stable equilibrium, unstable equilibrium, neutral equilibrium. You understood. Thanks for watching this video. Please subscribe my channel and tap the bell icon to get the notification whenever I upload new videos regarding physics. Thank you.